So I'm Kishore Seshadri. I'm the VPGM of the SD-WAN and the user experience business here at Aruba. And today we're going to talk to you about something a little different from what Aruba usually presents to you. We're well known in the wireless space and the wired space, and we haven't really said a lot about what we do in the WAN space. Aruba has been widely deployed in a lot of different branches, primarily as remote APs. And we have a fairly large footprint there. But we started down this path about 2.5 years ago. And as Partha said, we're really all about user experience. And we realized that as an increasing percentage of the traffic in a branch starts to go to internet destinations, controlling user experience, it's not enough to control just the access layer. Customers sort of perceive any problem with the network as, hey, my Wi-Fi has a problem. And if we really want to manage experiences and give customers good experiences, we have to control both the WAN piece as well as the access piece. So today we're going to talk about what we do. We launched a solution about I think a little over a year ago. And we would have been the 50th or the 40th SD-WAN vendor if we had just done this as SD-WAN. And so we talked to a lot of different customers, and we came up with a different approach that we call SD Branch. So today we'll go over what SD Branch is, how it's different, or how it relates to SD-WAN. And in this session, we'll give you a quick context about what our thinking was, why we approached the problem the way we did, what SD Branch is, and what we've seen so far in the market. And then Ramanan will go over, give you a solution overview. So I think this is a picture that's familiar to a lot of you. This is the world pre-SD-WAN. A lot of us have lived in this world and grown up in this world. This is a place where you had branch gateways connecting to a private WAN, typically MPLS, connecting back to a data center, which was then connected to the internet. And I would say 90% of the traffic headed back from the branch to a service or a server that was sitting in the data center. So the traffic patterns were fairly predictable. Most traffic went back. The control plane was distributed. A lot of customers managed this using a distributed management plane, really CLI, into each router. And security was also centralized. You typically had firewalls and a DMZ back in the data center that then sort of looked at traffic going in and out to the internet. Branch connections themselves were low bandwidth. T1s, E1s was very, very common, and these were guaranteed SLAs and fairly expensive and difficult to change. And this is a world that existed for 20 years. So circa 2014, 2015, we had the emergence of SD-WAN. And for the first time, you saw a centralized control plane and a centralized management plane as well. So I think some of the early SD-WAN vendors recognized that managing a large distributed network of routers, especially if it was in the hundreds to thousands, was a challenging problem. Done through CLI was excruciating. Things like DMVPN were very, very complex for the typical customer to set up. And teams were getting smaller as well. So SD-WAN set about to solve this problem of how do I make this large distributed network simple to manage. And started using cheap broadband links multiple cheap broadband links to emulate business class services. The internet itself had changed sufficiently by then. Most service providers were cloud service providers, and SaaS providers were starting to appear close to the edge of the network. Bandwidths themselves had grown to a point where the quality of service was reasonably good. You had multiple paths across the network. And you could use these cheap broadband links to give you a reasonably good simulation of a business class service. And in the early days, the majority of the traffic was still destined back to the data center. And the value propositions for SD-WAN 1.0 was really around cheaper, simpler WAN. Right? It was cheaper than MPLS. It was easier to manage. It was simpler. And a lot of the deployments we see today are still very much fit this mold, where you have an SD-WAN gateway that's often used in conjunction with an MPLS router. It's used to either augment bandwidth or in some cases to replace the MPLS router. So this is very, very typical. So moving forward, this is a bit more cutting edge in what we see in terms of SD-WAN. What has changed significantly is that in addition to this centralized control and management plane, IPsec overlays, those are all sort of well understood. We're starting to see the emergence of cloud security services. And interestingly, the value proposition is no longer just about cheaper than MPLS, but it's really about how can I get to SaaS and cloud as quickly as I can? What are the lowest latency paths to get to SaaS and cloud? And that's becoming the predominant factor that drives the design. The branch connections are still very much the same, though broadband bandwidth seems to be doubling about every 3 years, and which means that whatever gateway you put in there has to be able to live in the network for a while and be able to absorb bandwidth growth. And an increasing percentage of the traffic is headed to the internet. A majority of these flows are starting to be encrypted. They're SSL in some form. And a lot of the internet traffic now goes through either a security service or in some cases, some customers have colo facilities where they deploy their own security services and then feed it onto the internet. You have a McAfee message.
I have no idea what it is.
So not everybody deploys this model as yet, but I would say this is starting to become an emerging model. And this is the world we sort of entered when we started going down this path about 2.5 years ago. I think this was pretty clear that this is where the trends were going to. And we talked to about 60 to 70 different customers about the problems that they were experiencing. And interestingly, while SD-WAN was often the conversation starter, it turned out that customers had many other problems in the branch. And I'll give you an example. I talked to a large retailer who was fairly representative of a broad customer base.
This is the one where we see.
And this retailer had about 2,000 to 3,000 sites. Each of these sites was fairly large. And they had a router, they had a firewall, they had a WAN optimization device, they had multiple devices in the network. And they were considering going down the SD-WAN path. But what we also found was that IoT was starting to become very real. They had many different types of devices. There were refrigerators that were on the internet. There were clocks on the internet. There were fryers on the internet. And for each type of device, they didn't really have any idea what the provenance of the stack was, how secure it was, how safe it was. And being sort of security-minded guys, they assigned each of these devices to a different subnet. Right? Every new device type got its own subnet, got its own VLAN. And the management software was written to place ACLs in switches and routers and firewalls. And you knew that a refrigerator always had the same low-order bits, so you placed an ACL to look for that. And even with just 3,000 locations, they were running out of private IP address space. So the number of ACE entries that they had in the routers were exceeding the capacity of the router. So the complexity of the network was huge, and in a sort of a strange inversion, they were building the network to adapt to the management software. The management software wasn't being written to adapt to the network. And we thought this was unusual, but we found that over and over again we saw this. Just a VLAN sprawl in the branch, policy expressed everywhere, policy enforced everywhere, no single place to configure policy and make a change to the network. So managing access control was very difficult. Very few people used NAC in branches. And having a secure remote location was a really hard problem. So we felt that the branch had a much bigger problem than just the WAN piece. So we set about to solve the entire branch problem.
So I've got a question for you in your previous slide, as you laid out the architecture of the I guess it was the SD-WAN 2.0 architecture, and I noticed you've got IPsec in the transport there. One of the things that we're finding in dealing with SD-WAN is that sometimes it doesn't always work exactly right because there's a number of protocols that are required for it. NAT traversal doesn't always work right if you have if you don't have a public IP address. And in some places in the world, IPv6 may be your only connectivity. How are you addressing those kinds of challenges in building this overlay transport?
Yeah, I think your question has multiple aspects to this. One is this whole onboarding process. Everyone claims to have ZTP. It really depends on the environment where you have to onboard, right? like you're saying, in some environments you'll have static IP, some environments you may have PPOE, DSL connections, where you'll need username, password. There's some level of one-touch provisioning that is required initially to get the initial connection up, after which all the ZTP process and magic really kicks in, right? So it's not always as seamless as everyone would explain it to be, and that's what our realization is as well. We have done a few things to enhance that, but still, there is some level of manual work which has to be done in some of these scenarios. V6, I'll get to V6. So V6 is something that today we support. We don't support it as yet, so I'll be very transparent.
And that's in the underlay or the overlay, or both?
No, so the way we split it is there's LAN side V6, like your V6 clients that are joining the network, and you have WAN side V6, and there in the WAN you can have underlay and overlay, right? Broadly speaking, is that a fair categorization, right?
Sure.
So I think right now for us, we have the LAN side V6 covered to a great extent. In fact, we have pretty large campus deployments where we are putting V6 in the same hardware, and I'll go through the solution components where we are deploying it. The access switches, the access APs, the gateways. The WAN is something that we are adding. We don't have it as yet, both on the underlay and the overlay. But it's only a question for us of, all the basic bits are there, DHCP, V6, DNS, all that stuff is there. It's just a matter of getting it tested, qualified for us, and getting it operational in networks. So that's where we are at. So I would say early next year is when we'll start to get those capabilities.
Gotcha. So back to my original question, do you have transports outside of IPsec, I guess was my specific original question.
Correct. So in terms of the overlay transport, so today it's all, if you look at the default is IPsec, right, which is the encrypted transport which you need for, over the internet.
Right.
We also support GRE, and you can do GRE over IPsec, and all those combinations get into that. So we support all of those, yeah.
Any plan to look at any kind of an SSL overlay where you would be doing 443 to make, because there's a lot of environments where 443 may be all you're getting through?
That's a great point. Yeah, so that's something under consideration. Yeah, you're right.
Yeah.
But in terms of, we don't use it for data plane. All our management connection and control connections are TLS, SSL based to our management agent. But in terms of data plane itself, we're not using SSL.
Gotcha, okay.
Yeah, we are starting to see countries where SSL may be the only option.
That's right.
I do a lot of international work, and that's a real challenge in some places.
Yeah, so we have a few customers who are rolling the solution out, and 4500 gets blocked in certain countries, like you're saying. And so it's a matter of just getting it added for us.
Okay, cool. Thank you.
Yeah, so the approach we took was slightly broader than just the SD-WAN approach. We call the approach SD Branch. And this is a somewhat simplistic representation of it. It's meant to be a marketing message, where we think of SD Branch as comprising of three components. There's an SD-WAN component, and this has to be a full-featured SD-WAN component to support the kinds of networks that I just talked about. There's an SD-LAN component that addresses the problems that I described, which is how do you avoid VLAN sprawl? How do you microsegment a branch into segments of one? How do you provide access control where you have a single place to configure policy, a single place in the branch to enforce policy, and then all of this in a wrapper of security. And it turns out that the gateway is the one point in the branch network where all these components come together. And again, looking at this in a pictorial way, this is the network. Everything inside the branch we consider as SD-LAN. Everything between gateways we consider as SD-WAN. And security shows up in multiple places depending on, sometimes on the class of traffic, on the security team's guidelines, and we'll touch on those at different points during the day.
The feedback analyst.
Yeah. So we've been very happy with the feedback that we've got to date. Some of the analyst feedback has been extremely positive. Most customers that we talk to start the conversation talking about SD-WAN, but then they see the value of SD Branch. These are not just Aruba customers, but greenfield customers as well. And some of the things that people like is, just even from a purely SD-WAN perspective, the gateways that we sell can scale to 2 gig and 4 gig of crypto throughput. And we don't have bandwidth tiers in our licensing, so we have a very simple licensing model. So once you do a truck roll and install a gateway, it's typically good in the network for 5 to 6 years. And the other value proposition is that this is a single pane of glass. And you'll see this at different times during today's demonstrations, that you start with a global view of the network, and then you can drill down all the way to a single client and the set of applications that that client has. And being able to do that all the way from the top level down to the lowest level from a single pane of glass is hugely valuable for a network administrator. So I wanted to talk about what's different in SD Branch from an implementation point of view. If you look at a typical SD-WAN gateway, typically the gateway sends out probes across all these different paths and characterizes these paths. You have a picture of loss, latency, and jitter across all available paths. You have a way of fingerprinting applications and identifying applications. And then you have an admin who configures policy that says, Teams is the application I care about, and this is the SLA I need. And it's typically the combination of probe data, admin policy, plus application fingerprinting that goes to form SD-WAN. What we've done in addition to all of that is by having visibility into the access layer, we have access to a whole lot more information. So we know the identity of the user, if there is a user associated with the client. We know the type of device it is. We know the role that's been assigned to it. We know the location of the device. We know the reputation of the destination that it's going to if URL filtering is enabled. We can create a risk profile. So we have a huge amount of context about the endpoint. And we use this context not just to make decisions on path selection to the WAN, but also on access control decisions inside the LAN. And it's that combination of context for routing decisions and access control decisions that we collectively call SD Branch. I hope that makes sense. So these are some examples of what you would do with this additional context. And here in this first example, Sue in accounting needs access to Salesforce CRM. So you need to be able to identify that, first, this is a Salesforce application, but you also need to know who the user is, that they've been assigned a role of accounting, and you need to pick a path, an MPLS path over the broadband path. So it's not just that all Salesforce traffic goes one way and everything else goes the other, but it's a specific user for a specific application. A second very common use case is a point of sale device on the local network needs to access the local payment server, but absolutely nothing else. Right? It's a very strict access control. You want to make sure that malware in your cameras doesn't have access to the point of sale device. So being able to configure these kinds of policies. And finally, YouTube is commonly used for employee training, but it's also used by people who are on your guest network. So you want to make sure that you can give priority to employee traffic who are using this for training rather than guest traffic. So being able to configure these kinds of policies without any hardwired IP addresses. So none of the policies we configure are reference an IP address. The policy is literally configured in a very English-like specification where you say cameras can talk to security team or to the surveillance team. And it's as simple as that. The IP addresses are learned dynamically as the session comes up, as the client becomes active. And internal to the system, we use IP addresses to enforce those policies, but the admin configures them in a very, very simple way. So policies are dynamic. Policies follow the endpoint. And that simplifies the entire branch network. Anything you want to?
Let's go on. Short of time.
So we're running short of time. Quick note on traction. You just click this.
Yeah.
So the solution's been generally available for a little over a year now. And at this point, we're deployed across a wide range of geographies, across practically any vertical that I can think of. And in terms of characterizing how widely deployed this is, the term that we use to track this internally is design wins. How many branch design wins do we have? Because typically when you win a customer who may have 1,000 locations or 2,000 locations, the schedule and the rate at which these get rolled out is often controlled by the customer. So we track these as about 50,000 plus design wins. We're in over 100 POCs at this point. The single largest customer or tenant, as we think of them on Aruba Central, this is all part of Aruba Central. The single largest customer we have has about 14,000 something locations and 100,000 devices. So given that previous slide where I talked about all the context that we have, we track state on 1 million sessions just for one customer. So if you think of a typical SD-WAN implementation, that only has to scale with the number of gateways. So we have to do 2 orders of magnitude more. We have to track every access device, its access switches, its access points, and then we track clients, and then we track applications within clients, since you want to be able to drill down all the way from the network view to a single application of a single client. So we have a million clients in this single customer's network, and that's the largest deployment that we have.